we start today's video talking about functions. So here's how the book defines what a function is. You can go ahead and read it over. Okay, a function f from a set A to set B is a relation that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain or set of inputs of the function, and the set B contains the range or set of outputs. And here are characteristics of what a function is. Each element in A must be matched with an element in B. Some elements in B may not be matched with an element in A. Two or more elements in A may be matched with the same element in B, and an element in A cannot be matched with two different elements. Okay. When I talk about functions and introduce functions, especially to like my Algebra 1 or Algebra 2 students, I like them to have a visual image of what a function may look like. So here's a very rough drawing of an input-output machine, or in other words, a function. So here are your inputs. Usually we use x, and then what comes out of the machine then would be f of x. So f, therefore, is the name of this function, okay, and or name of this machine, and what the machine does is whatever the equation of the function is, or y, and that's your output. Okay. So if a machine is set to do one task, let's say it's multiplying by 2, or maybe it's two things like multiplying by 2 and adding 3, then for whatever x value you put into the machine, it'll always give you the same y value. Now, it's possible to have the same output or y value if you put two different inputs in. So for example, if this machine is a squaring machine, then if you put in positive 3 or negative 3, you'll still get the same output of 9. Okay, so anyways, think about the characteristics of a function just in the context of this machine image for a couple seconds, and then we'll move on. And then the book tells you that there's 4 different ways that you could represent a function. So those are verbally, numerically, graphically, or analytically. The last one's an equation. Graphs, of course, are graphs. Numerically, usually we use tables or lists. And then verbally, it's just describing it in words. Example 2 asks you to analytically tell whether different relations or equations represent functions. So basically, you could tell analytically based on whether you could write the equation as a function of x, where you could isolate y and represent it as a function of x. So in the first one, you could isolate y by subtracting x squared, and so this represents a function, because no matter what x value you put into it, you will get one y value. In the second one, if you solve for y, square rooting both sides gives you a positive or a negative value. So here you could tell it's not a function, because if you were to give a value of x, let's say like x equals 0, then you would get 2 different values of y. So one input cannot give you 2 different outputs. That would indicate that the machine doesn't work, or in other words, it is not functional. You like that? Okay, and then the third one, we're going to add 2, so y equals 2 is the equation, and so this is a function because the absence of an x in the equation tells us that we can put any x value we want. We can input anything we want, and the function will always spit out the number 2. Okay, it's a constant function. This example just wants to make sure that you understand how function notation works. So here you have this function, g of x, which, by the way, let me just take a moment to talk about that. I'm sure you guys all know this, but it's worth mentioning. G parentheses x, the way you read it is g of x. G by itself is just the name of the function. Okay, g of x is the value of the function at x, or in other words, with input of x. Okay, so sometimes Algebra 1 kids especially think that you're multiplying g times x. It is not multiplication. Okay, it's just the function notation for the function that they call g. So moving on to A, we have g of 2. So basically they want to know, if you input 2, what do you get out of this machine? Okay, very trivial example. You just plug in 2 for x and work it out. And you're going to get negative 4 plus 8 plus 1. So g of 2 is equal to 5. Okay, input 2, output 5. Now g of x plus 2 just means that wherever you see x in the function, you're going to replace it with x plus 2. So it'll be like this. Okay, you got to FOIL this one out. Distribute here. And then collect like terms after you distribute the negative. So you get negative 4x plus 4x, so the 4x's will cancel. You got negative 4 plus 9, so plus 5. Okay, so that's g of x plus 2. In this example, they give you a piecewise function. So a piecewise function is a function that is defined differently for different parts of the domain. So for example, in this one, you have this function f. So it's still just one function, but you determine the output of the function based on what the input is. So whenever you look at a piecewise function, your focus should be first on the interval on which the particular parts are defined. So if you're inputting an x value that's less than 0, then you would use this rule. Whereas if you put an input value greater than or equal to 0, you would use this rule. Okay, I'm going to skip the rest of this because this video is getting long, so you could read it by yourself. Okay, example 5, they want you to find zeros, or in other words, find out where the function f of x is equal to 0. So zeros are simply the x values or input values that make the function equal to 0. I'm going to, again, skip this example. You guys could read it. It's quite simple. Okay, now let's talk about domain. So the domain of a function is the set of all real input values for which the function is defined. Now, sometimes when you have a function, there is what we call an implied domain. So for example, when you have f of x equals x squared minus 4, it is implied because it's well established that you cannot divide a number by 0, right, because it's undefined, that you can't divide by 0. So therefore, in this particular function, we can see that x cannot equal positive or negative 2, right, because that would cause division by 0. So that is implied. It is implied that x cannot be positive 2 or negative 2. Okay, that's implied. Now, if you want to explicitly state it, then you would say x cannot equal plus or minus 2. Okay, but just the very nature that it's a rational function where division by 0 happens with those values, that is implied. Oops, sorry about that. Okay, similarly, if you have a square root or even radical expression, like, oh my goodness, let me get out of highlighter mode. Okay, sorry about that. Like f of x equals the square root of x. Okay, everyone knows that you can't square root a negative number. So it's implied here that x has to be greater than or equal to 0. Okay? That being said, if you actually have to find particular domains, let's look at the next example to do that. So in these problems, they want you to find the domain. I'll just go through these really fast. So the first one, it's just all the x values. And usually we like to put those in order. Oops. So the domain here is smallest one, -3, -1, 0, 2, 4. Right, those are the x values. Okay, letter B, you can see that x cannot equal -5. So if we want to state the domain, we could just say x cannot equal -5. Now, just a word about that. When you indicate the domain of a function, you can either indicate it in the affirmative, meaning you can say what x can be, or you could also say it in the negative by saying what x cannot be, which implies that it can be anything else. So when you say that x cannot equal -5, you are implying that x can be any other real number. Okay, looking at C, since we're talking about the volume of a sphere here, the radius, therefore, right, the domain here is that the radius must be greater than 0. Can't be negative, can't be 0. For D, it's a square root function, so what we know is that the inner part of the square root function must be greater than or equal to 0. Okay, and we've solved these types of problems before. We know that the domain is all real numbers between -2 and +2 inclusive. And then for E, it's just a regular parabola, right? Regular quadratic function, which means that x can be any real number. There's nothing that'll restrict what the value of x can be. No division by 0, no radicals, nothing like that. So therefore your domain here is all real numbers, which this is the shorthand to say that x is the set of all real numbers, or is an element of the real number set. Finally, we have example 10, which is kind of a random example, but they throw this in there because this difference quotient is a preview to what we're going to be seeing in calculus. So there's the difference quotient, and they want us to apply it for that function. Okay, so let's start with the first one. We have f of x plus delta x. So how do we do f of x plus delta x? Well, the meaning of it is that you're going to replace wherever you see x in the function with x plus delta x. So that's going to give you x plus delta x squared minus 4 times x plus delta x. Okay, so it's going to be x plus delta x squared minus 4 times x plus delta x plus 7. Okay, so all of that is f of x plus delta x. Pause it if you don't get it and make sure you get it. Okay, the next part of the difference quotient is to subtract f of x. So we're just going to subtract the function, which is this. And then you're going to have to divide the whole thing by delta x. Okay, so you FOIL the first part. You get x squared plus 2x times delta x plus delta x squared. Distribute the 4, or -4, so minus 4x minus 4 delta x plus 7. And then distribute the negative, so negative x squared plus 4x minus 7. And the whole thing is still being divided by delta x. And now what you'll notice is that certain terms will cancel out. So for example, I've got an x squared here and a negative x squared here. So those will cancel out. I've got a negative 4x here and a positive 4x here. So those will cancel out. I've got a positive 7 and a negative 7. So those will cancel out. Now, if you look at the remaining terms on top, all three of them have a delta x in it. So you could factor out delta x on top, and you're left with 2x plus delta x minus 4 all over delta x. So now you can cancel the delta x in the numerator with the delta x in the denominator, and you are left with 2x minus 4 plus delta x. Okay, now the meaning of this you're not going to learn for a little while, but you do have to know how to execute this type of function. Okay, that's it.